When you're writing programs that involve classes and objects, you'll often find that as soon as you construct a new object, there are certain attributes that you want to initialize to be different from their default values. And what we're going to learn today is a way of doing that as a part of the construction of an object. Now, that's a lot of terminology, so let's go and make this example a little bit more concrete. So imagine we're working with a class named point. And when we talk about a point, we're talking about a 2D point in a Cartesian coordinate axis, where a point has an x attribute whose type is, say, float, and whose initial value might be 0 by default. And y is another attribute that's also of type float, whose default value might be 0 as soon as we are working with a brand new point object. So by defining a class, we're introducing the idea of a point data type. And we can use that in any other place we could use a data type, right? So if we wanted to say there's a variable named p and its type is going to be point, we could declare it as such, right? And so now p as a point is going to be something that can refer to a point object. Now we haven't yet initialized p, so we can't work with this point object yet. And in order to initialize a point object, we know that we need to assign a new point object to it. So I could say p is assigned a point. And what is this function call doing? Well, this is a special kind of function call that is constructing a new point object. When you use the name of a class, so our class name is point, as a function call, it has special meaning in our programming language. And what it will do is it will say, okay, let's go set up a new point object. So somewhere on the heap, there will be a point object constructed. It will have two attributes, x and y, that are by default, if we were to go and read these attributes, initially 0, because we specified these attributes to have these values as their default values, right? And upon construction, what this function call evaluates to, right? If we were thinking about what is p actually going to be, well, p is actually going to be a pointer to or an arrow to this object that's bound to refer to this object, right? So now that we've got this point object that we can work with, we would then need to go and say, okay, p.x is actually, 110.0. So the x attribute would be updated to 110, and p.y is, say, 211.0, and y would be updated to 211.0, right? Now, if we find that we're very frequently having to initialize these attributes just after constructing an object, it turns out there's a better way. Wouldn't it be nice if we could use point, like we can use other functions, that we can give specific arguments to? So we'd really like to be able to give, say, 110.0 as an argument and 211.0 as the second argument, and have that mean, or have the ramification of that be such that the x and y attributes would be initialized to 110 and 211 as soon as this object was constructed, like as a part of this construction object, or the construction of this object. So what we're going to learn today is the idea of a constructor. And a constructor is going to be something that we define in our class, just after our attributes typically, that will allow us to fully initialize an object as soon as we construct it. It's a special kind of function, so let's go look at how it works. As I just mentioned, the motivation for this idea is that we would really like to be able to fully initialize our attributes as soon as an object is constructed. So we'd really like to be able to write a line of code that looks something like this. Now I want to remind you that in this line, the typing of A is a point. A is a variable whose type is point. We can leave off that type hint that we're seeing here if we're initializing A to be a new point object on the same line, thanks to type inference, right? So how does a constructor actually work? What does it look like? Well, it looks like a special kind of function. So let me get out of the way here and talk through what a constructor looks like. So we've seen this class point, and you'll notice that I'm no longer providing default values for the attributes x and y, because we're going to define those as parameters on our constructor. Now this constructor is going to look a lot like something you're familiar with. We're defining a function here, but it's a little bit unique and special too, right? So one of the things that's unique is that its name is surrounded in 2 underscores. And when we're working in the Python language, we know that this means it has some special meaning to the language of Python. This dunderscore convention, or double underscore convention, is a clear indicator that this is a name with special implications. Right? But that is the name of this function nonetheless. Another thing that's weird is you'll notice there's no return type. We're not specifying this returns none. And we'll have to think very deeply about what the return type is because it has interesting, important implications. You'll notice there are two parameters here that look very normal, very natural, X and Y. They make sense in the context of the program. But then there's this very first parameter. This one is special, right? This one is unique. This is one that we're going to need to talk about how this works and what this is, and we'll reveal those details in just a moment, all right? You'll notice that in the body of this constructor definition, it sure looks like we're using the word self to mean a reference to a point object because we're saying self.x is assigned x, which is our parameter value that we're seeing here, and self.y is assigned y, which is our other parameter value. So sure enough, we can kind of, through intuition, resolve this idea that self must be a reference to a point object. And if we read into this word self, which is a special reserved word in the Python language that is used in this way specifically, we must be referring to myself. This must be part of this object. The idea of this object has some self-reference that it can initialize its own attributes as part of its construction, right? So why don't we go ahead and try setting up an example of this in VS Code, and I would encourage you to follow along. So in my lessons directory, I've gone ahead and set up a file named ls36constructors.py. I would encourage you to do that and resume the video once you're ready to continue on. And then I'm just going to go ahead and set up some code that will bring us to where we're at. And then we can implement this constructor together. So the code, the doc comment we'll write here is an example of a constructor definition, right? And we'll define a class named point. It will have an X attribute of type float and a Y attribute of type float. And then we will define the constructor, right? So the constructor is going to be, and let me just add an extra new line here. The constructor is going to be a function whose name is special. It's init, which is short for initialize, right? We're initializing a new object. And the first parameter is going to be self. This is that special parameter that will be given a reference to the object being constructed. And we'll look at exactly what I mean by that in just a moment. Then there are two parameters. X is the first parameter, float, and Y is the second parameter, also a float. And there's no return type specified here, right? And the only purpose of this constructor is to be able to say self.x is X and self.y is Y, right? And this is our fully specified constructor. So go ahead and pause the video here, and we'll come back to discuss what this is in just a moment. Great. So now that you've got the same definition that I do, I'm going to go ahead and add one more doc string here that is saying an example of a constructor. And I'll call this function method. In the next video, we'll discuss what the idea of a method is. And we tend to think of a constructor as a special kind of method, which is also a special kind of function. And the main implication, what makes it special, is that it's defined inside of a class and has meaning relative to our objects, right? So you'll notice that the definition of this function is indented entirely by one extra level of indentation so that we can imply that this belongs to the class named point, right? And my code editor is saying, hey, you need to add a doc string here as well. So a 2D point is how we can document this class fully, right? So we've got our doc string set up, and let's go and actually try making use of this, right? So now if I open a REPL, and I'm gonna just leave this here, I'm going to start a new Python instance. So now I'm at my REPL, and from lessons.ls36 constructors, import the point class, right? So now we've imported the idea of a point. And so we could say, you know, P is a variable of type point and it's assigned a new point object. And I'm going to try constructing a new point object without any arguments, and we'll see something interesting happens. Notice that if I try and construct a point object without those attributes or without those arguments here, we get an error. It now tells us that, hey, the init constructor is missing the two required arguments. We didn't give it arguments for x and y. So let's try a different way of constructing this point object. Let me try again. Right, so let's see if we can get it right the second time. So 110.0 and 211.0. Right? Okay, no errors. So let's see if we ask what is p.x? It's 110 and p.y is 211. So it looks like this object is fully initialized. All right, that's great. Let's try encoding this in a main function really quickly, and then we'll diagram what exactly is going on under the hood. All right, so I'm going to set up a main function, make this just a little bit smaller so a little bit more can fit on my screen here, and set up a main function, and this will be a function that returns none, and this is the entry point of the program. Easy enough. And the example we just gave, and I'll do this with type inference here, so I'm just going to say p is a new point, and print p.x and print p.y. Right? And you're probably wondering, well, hey Chris, aren't you forgetting those arguments? And sure enough, VS Code is even telling me I've forgotten those arguments, right? We're missing those arguments x and y. So let's go ahead and set those up, and I'll do, for the sake of carrying forward this example, the two courses I'm teaching this semester, 110 and 211. Here at UNC, and then we'll go ahead and add our idiom if name is equal to main, call the main function. All right, so now we've got our fully specified program here, and I'm going to make this once again just slightly smaller. All right, so I can just about fit everything on the screen. So we've got our class point, our main function, and let's imagine what happens when we evaluate this, right? And I'm going to try and give myself some extra room over here on the right so that I've got room to draw the diagram, right? So what is going on when this code evaluates? Well, in our stack, we've got our globals frame, right? And so our globals frame is going to have the names of our top level definitions, right? And so our top level definitions include the class point. So point is a class, and it's defined on lines 4 through 12, right? So that's the class on lines 4 through 12. So now whenever we use the point as a function, we know that it's referring to a class, so it must be a constructor call, right? And of course, this is our heap, right? And we have a function named main, right? So we're ready to go. This is a function defined on lines 15 through 19. All right. When we reach the line 23, that's where our call to main occurs. And so the return address is line 23. That's where we would go back to when this main function completes. Right? There are no parameters to set up, so we're ready to jump into this main function. So what do we see happens in this main function? Well, the very first line that we evaluate here is an assignment statement or an initialization statement. And we know that we need to figure out, well, what's going on the right-hand side of this initialization statement first. So this is a special kind of function call. We ask ourselves, okay, let's look in the diagram. Do we have anything named point defined in our main function frame? No. So the next place we're going to look is our globals frame. Do we have something named point defined in our globals frame? Yes, we do. It's bound to the class defined on these lines. So when you see a function call to a class name, we know that we're working with a constructor, right? So when you're working with a constructor, now that we know that we have these special kinds of methods, we can't just assume a new object comes out of nowhere and it's initialized with default values and our job is done. We need to look inside of that class and see if there's a constructor defined. The way that you'll know if there's a constructor defined in Python is we look for this special function named _init. And of course, here there is one of these. If there were not one of these, the previous rules that we looked at would apply. We would just go ahead and set up our empty object on the heap and be done with it. Right? Maybe initialize default values, okay? But here we've got a constructor, so we need to actually evaluate this frame. Well, how do we do that? All right, well, we've got some steps that are gonna work very similar to a function call with one caveat, all right? So I'm gonna go ahead and give myself some a frame to begin working with this constructor call. So the first thing that's different is we need to know, it turns out if we have multiple kinds of classes and each of them has their own init constructor, then we need to know, well, which init constructor does this frame actually belong to? So we'll use a convention of naming this the name of the class, so point, and then hashtag __init, right? So this is the name of the the constructor that we're calling, right? And this is of course going to have a return address, and the return address is going to be line 17, right? That's where this construction call occurs. And there are two parameters. Actually, there are three parameters. Let me back up. There are three parameters, right? There are only two arguments, but there are three parameters. So wow, it seems like something might be curious here. We don't really know what's going on, right? Where does this self parameter come from? We know this is valid. We just tried this and it worked. But what is self, right? So notice that you are not calling the point constructor directly, right? There's this something named init. You're just calling the class name point. So behind the scenes, the Python programming language is taking some extra steps before we reach line 9 and evaluate this function call, this constructor call. So what are those steps? Well, we've seen them before, right? So the first step that happens is we're going to set up a point object on our heap that's going to have X and Y attributes, and neither of them will have any default value associated to begin with, right? Because we didn't specify any default values up in the class definition. Okay, so that point object is going to be bound to this first parameter named self. All right, so we're going to have a parameter named self on our frame, and it's going to be bound to this brand new shiny point object that we're trying to construct and initialize. Right? That happens automatically, or we like to use the word automagically, behind the scenes without us seeing how it works. This is just part of the Python programming language, and every object-oriented language has some mechanism for doing something very similar to this. Right? Now, from here, it works more normally, where we have, okay, this argument 110 is going to be assigned to the X parameter, right? So X is going to have a value of 110. And Y is going to be the second parameter that's going to have a value of 211, right? So we've set up these two parameters inside of this constructor call. And now we've set up our return address, we set up the name of our frame, we set up our parameters, and we're ready to finally jump in, right? So this is what goes into setting up the constructor frame on the heap, or on the stack, and the point object that we're constructing on the heap. And now it works pretty normally, right? We see an assignment statement where we say, what is X? Well, X is the value 110. Well, what are we doing with 110? We're assigning it to the left-hand side of this assignment statement, right? We're assigning it to self.x. Well, what is self.x? Self, and then dot means follow this arrow, and X is this uninitialized previously attribute, but we're going to initialize it to 110.0, right? That was the effect of line 11. We do the same thing with line 12, right? We look up what is Y. Well, Y in this frame has a value of 211. So we take that value and we assign it to self.y. Self.y is this space here, and it's going to have a value of 211. And it looks like we're done, right? Now, the next part of a constructor that's special is, and we're going to take our own convention here that's a little bit unique to help us understand what's going on. We're going to assume that the return value of this init function is actually a reference to this point object, right? So what we will say is the return value of this constructor is a reference to that point object that it just constructed, right? We're sending that reference back to line 17 where this constructor was called, right? So now on line 17, we're finally ready to initialize P in main to be a reference to the point or the return value of that constructor, right? So let me just back up and say that one more time. When we reach the end of a constructor, what we're going to assume is happening is a reference to the object that we just constructed and initialized as part of the constructor is returned. And where it gets returned to is wherever that call occurred. And so here, that call occurred on line P. So now P is going to be initialized to refer to that object that was just constructed. So your constructor frames will have this automatic parameter set up named self that refers to the uninitialized object, and then they'll return a reference to this point as well. Great. So from here, it's very straightforward. When we reach line 18, we ask what is p.x. This would print out. So my output of p.x would be 110.0 at this point, and p.y would be 211.0, right? So hopefully what you're getting a sense of is this is a handy way of being able to define a special kind of function, which we'll see as a special kind of method as well, named a constructor. And in Python, a constructor has a special name called init. In other languages, they'll choose other things. That's okay. You can learn that when you get there, right? But in Python, when you see an init function that's surrounded in double underscores, defined inside of a class, we know that that's a constructor. And what that gives us the ability to do is more flexibly work with new constructed objects and specify that, hey, there are certain attributes, in this case, the X and Y attributes, that you really, really want to initialize as soon as an object is constructed, right? Now, you don't have to specify every attribute. We could have some attributes that have default values associated with them, and that's totally fine as well. All right. So going back to just a few more notes in the slides, there are some semantics that we just talked through, and I'll repeat them here for good measure. Once again, a constructor is a magic method, meaning it's one that has special meaning and works a little bit differently from other kinds of methods. And we'll see how regular methods work in the very next video. We define this inside of the class, and it looks a lot like a function, with the exception of it has a special first parameter named self. And self is going to be, its type is going to be class point, right? It's going to be a point in this example, but it's going to be whatever type of object it's defined it's defined inside the class of, right? And because we know that, we never specify it. This is just assumed that is what it is, right? And it also doesn't have a return type specified. And we're going to assume that it returns a reference to whatever self was, right? So it's always going to return a reference to self. Now we're waving our hands there a little bit. It's a little bit trickier than that, right? Because we didn't actually call this function directly. So Python is doing some clever things behind the scenes to actually ensure that that reference is returned back to where it came from. But for our purposes in diagramming and understanding the semantics of how this works, let's just assume that this constructor returns a reference to self. All right, or whatever self refers to. And as we've seen, whenever we use a constructor function call after defining one of these, we have to now go do some extra work. We have to evaluate a frame on the stack and be sure that our arguments are in agreement with our constructor's parameters, right? So we ignore the first parameter because the programming language runtime system sets up that value for us automatically. And then we check the parameters that come after that. So we need to be sure that there's two parameters, X and Y, and they're both float values. We'll look at some additional examples of working with constructors in the videos ahead, and we'll look at methods in the very next video. What a constructor gives you is the ability, what a constructor gives you is the ability to define a special kind of function that makes constructing new, fully initialized objects easier to work with and more less error prone to write. Right? So after you define a constructor, you know that if you're requiring certain arguments to be given as part of the construction process, someone must give you those arguments in order to construct a value, which will enable you as the person authoring a class to have some guarantee that your objects will be fully initialized before people can start actually using them. And this is an important guarantee. Let's take a look at methods in the very next video. Great work on constructors.